Our next point of discussion here for filling out our trig table is to work through what are sine, cosine, and tangent of 30, 45, and 60 degree angles, or for dealing with radians, pi over 6, pi over 4, and pi over 3. We are kind of our first angle language is degrees. It's not radians, so we're going to talk about this in degrees, but it also works for the radians. So what we're going to do, we've looked at these triangles before, so we're going to take some special triangles here, which we've already discussed, and find sine, cosine, and tangent. So this is a 45, 45, 90 degree triangle that's sketched here. So 45, 45, and 90. We have looked through this before. We can use Pythagorean theorem to help us with this, but this, if we called both of these 1, we could solve Pythagorean theorem and know that this is the square root of 2. These two are both the same because it's a right isosceles triangle, so we can know they're the same. And so we can just go through here and we can find sine of 45. So looking at this 45 degree angle, that's opposite, which is 1 over hypotenuse, which is root 2. So the square, 1 over root 2, if we were to put that in proper radical form, it would be root 2 over 2. Just so you remember, we would multiply top and bottom by root 2 to change it to that form. Next, we can find the cosine of 45. Cosine of 45, still looking at this, it's adjacent over hypotenuse, so 1 over root 2, which is exactly the same as sine. That's also root 2 over 2. And then tangent of 45 is opposite, which is 1 over adjacent, which is 1. So tangent of 45 is 1. So in our table, we can look at a 45 degree angle. Sine and cosine are both root 2 over 2. And tangent is 1. So as we look at this table, if we want to find the cosine of 45, we look at 45 here, and the cosine here, and right there is cosine of 45, or again, if we're talking about radians, cosine of pi over 4. Now down our next triangle, there was a little bit more legwork to get this one. What we actually started with was a equilateral triangle, and we called each side 2. But if we drew in this altitude right here, this side would just be 1. And we could use Pythagorean theorem when we found that this side is root 3. So again, it was equilateral, which means all of them are 60, but when we split this in half, this would be 30 degrees. And so we can use that triangle to help us find sine, cosine, and tangent of 30 degrees and 60 degrees. So, and yeah, sine, let's start with 30. Sine of 30 is opposite over hypotenuse, so 1 over 2. Nice and easy, 1/2. Cosine of 30, that's adjacent over hypotenuse. That's root 3 over 2. And then tangent of 30 is opposite over adjacent. That's 1 over root 3, which if we do change that, it's going to be square root of 3 over 3. And so there's sine, cosine, and tangent of 30. And we can go ahead and find sine, cosine, and tangent of 60. So sine of 60. So now we're looking at the 60 degree angle, opposite over hypotenuse, which is root 3 over 2. Cosine of 60, adjacent, which is 1 over the hypotenuse, which is 2, so 1/2, and then tangent of 60 is, so here's 60, it's opposite, square root of 3 over adjacent, which is 1, so we can just write root 3. And so now we can fill out those first rows for sine of 30 and sine, cosine, and tangent of 30 and of 60. So this was 1/2. So I'm just looking down here at what we had before. Cosine was √3/2 and tangent was √3/3. And then for 60, we have sine of 60, √3/2. Cosine of 60 was 1/2, and tangent was √3. So we found each of those angles, trig ratios of those angles. And again, we found them in degrees, but they definitely match up if you have things in radians as well. Well, we can actually finish a lot of this chart now, putting the last two pieces of information together. See, once we have our reference angles, so here's a 60-degree angle. That's going to be the same as sine, cosine, and tangent of 60 here, except we have to take into account the signs, whether it's positive or negative. And we know that in the first quadrant, all were positive. In the second quadrant, sine was positive. Third quadrant, tangent's positive. And fourth quadrant, cosine is positive. So we marked the certain values negative in our last video. And so now it's just referring back to those reference angles to help us figure out the rest of this chart. So as we look at 120, reference angle of 60, we can refer back to our 60-degree row here. So its sine is √3/2. Cosine of 60 is 1/2, but since we're in the second quadrant, cosine's negative, so it's -1/2. And similarly, tangent is -√3. Going to the next one, we have a 45-degree reference angle. So we're looking at this one, which is a reference angle of 45, so it's going to relate back to this row right here, except our signs will be a little bit different. So √2/2, -√2/2, and -1. And then 150, that has a 30-degree reference angle. So we're going to look at our 30-degree, and we can fill those out with the proper sign, positive or negative sign. So that's going to be sine of 150 is 1/2. Cosine of 150 is -√3/2, and tangent of 150 is -√3/3. And we could fill out the rest of this chart using that same method, checking with the reference angle and filling it in. So this will be 1/2. And down to the fourth quadrant. Again, check the reference angles. In this case, cosine is positive. And so most of our chart is filled out now. We just have to work with what are called the quadrantal angles. But we have all of our special angles filled out in the 4 different quadrants. And we were able to use what we knew about sine, cosine, and tangent of 30, 45, and 60. And we were able to use what we knew about what was positive or negative in the 4 different quadrants.